Hello class, welcome to Algebra Concepts Lesson 4.2, which is all about rate of change and slope. By the end of this lesson, you should be able to find and interpret the rate of change and slopes of lines. So let's first talk about finding rate of change from a table. So rate of change just means your change in y over your change in x. So we did a little bit of this last chapter when we were talking about like if things were linear or non-linear, and something we talked about was figuring out, okay, how much does it change going from here to here? Going from 12 to 24, that's positive 12. Going from 24 to 36, that's also positive 12. And then checking my x's, going from 2 to 4, that's positive 2. And going from 4 to 6, that's also positive 2. So in this case, our rate of change is constant, right? We have the same numbers on the x and the same numbers on the y. But then to figure out what the rate of change is, you do your change in y, which was 12, over your change in x, which was 2, and you simplify. So you would say 6 is your rate of change. You get, and if we talk about what that means in relation to the table, we see that x represented the amount of flour and y represented the pancakes. So it'd be 6 pancakes for 1 cup of flour. Okay, so I want you to look at this table. It's the amount of money Shamar earns y after working x hours is shown in the table. Find the rate of change. Good luck. Okay, so hopefully you figured out the change in y was $31 and the change in x was 4 hours. So if we do $31 divided by 4 hours, we figure out that he earns $7.75 per hour. So that would be our rate of change. All right, example 2. The Jackson High School Student Council budget varies based on the fundraising of the previous year. Find the rate of change for 2000 to 2005 and describe its meaning in the context of the situation. Okay, so that's part A. 2000 started at $13.50. 2005, it got up to $16.75. So those two numbers are my y values. So I would say 1675 minus 1350 over, and then that 1675 was my 2005 year. So I would list 2005 first, and 1350 lined up with the 2000. So I'd put 2000 second like that. And then what I'm going to do is I'm going to say 1675 minus 1350 for the top, and that gives me 325. And then 2005 minus 2000 is 5. So if I do 325 divided by 5, I find out the rate of change is $65. And if we look, it's going up, right? It went up to 1675 from that 1350. So that means each year, this is how much it increased from 2000 to 2005. It went up 60, or their budget, that's what I mean by it, sorry. The budget went up $65 every year. Now let's look at the rate of change for 2010 through 2015. So 2010 started at 1550. So if I do 1550 minus, and then on the bottom I'm going to do 2010 minus, and then I have 1325 over 2015. So 1550 minus 1325 is going to give me 225. Divided by 2010 minus 2015 is negative 5. So if I do 225 divided by negative 5, I get negative 45. Oops. Negative 45. So in this context, it means that their budget actually went down $45 per year during that time. Okay, so a slope can tell you whether things are increasing or decreasing and how quickly. Okay. Now let's look at example 3, which is determining if a function is linear. If it is, you state the rate of change. So in order for something to be linear, it has to have that constant rate of change. Okay, so if we look at this, I'm going to start with the y's. So going from -5 to -3, I added 2. -3 to a -1, I added 2. -1 to a +1, I added 2. 1 to 3, I added 2. To go from, okay, so all of my y's are the same, so that's a good start. And then my x's, 11 to 8 means that I subtracted 3. 8 to 5, I subtracted 3. 5 to 2, I subtracted 3. 2 to -1, I subtracted 3. So since all of these are the same, so the y's are all 2's, the x's are all 3's, this function is linear, and its rate of change is your y over your x. And then that negative just gets put in front of the fraction. So you would say it's linear and its rate of change is -2/3. All right, so now I want you to determine, is this function linear? And if it is, state the rate of change. Good luck. All right, hopefully you said that this is linear and the rate of change is 2/1 or just 2. If you have questions about that, please be sure to reach out for some help. I'm happy to help you. Let's move on to our next example. Okay, so again, we want to determine if this is linear, and if it is, we want to state the range. So checking my y's, -4 to a -1, I added 3. -1 to a 1, I added 2. 1 to 4, I added 3. And 4 to 6, I added 2. Okay, and then over here, 22 to 29, I added 7. 29 to 36, I added 7. 36 to 43, I added 7. And 43 to 50, I added 7. Okay, so looking at this, my x's always changed by the same amount. Oh, sorry, can't stop yawning. My x always changed by the same amount, but my y's, notice it alternated between 3 and 2. And so even though this is a pattern, right, it went 3, 2, 3, 2, it is not linear because these have to be the same number. If your x's are the same number, your y's have to be the same number. Okay, so this is non-linear, which also means it does not have a rate of change. Okay, so now we're going to find the slope of the line that passes through 2 points. So we did this a bit last year. So this is where you take an ordered pair and you subtract your y's, and then you subtract your x's. Okay, so sometimes I find it helps students if they name their points. Okay, so then y2 is 7 minus y1 is 4 over x2 is 1 minus our x3, which was a -3. So 1 minus a negative becomes plus. So I have 7 minus 4 is 3. 1 plus 3 is 4. My slope is 3/4. And if I were to see it on a graph, this is what it would look like. You could see I went up 3 and I went to the right 4. So 3/4 is how you would read it from a graph. Okay, now let's find the slope of a line that passes through -1, 3, and 4, 1. So again, if I say x1, y1, x2, y2, I'd say 1 minus 3 over 4 minus a negative becomes plus 1. 1 minus 3 is -2 over 5. So my slope is negative 2/5. You can either keep the negative up top or you can write it in front of the fraction. That's what you'll see me do most often, okay? And this is what it would look like on a graph. You can see I went down 2, but then I still went right, which is positive 5. Okay, so negative 2/5. Let's keep that habit. Let's subtract our y's and subtract our x's. So I have x1, oops, that was weird, x1, y1. Not sure why this isn't grabbing. So I'm going to move it quick. I'm going to slide that down and see if it'll let me write above it. So we have x1, y1, x2, y2. Okay, so negative 5 minus a negative becomes plus 5. And then 4 minus a negative becomes plus. So on top I have negative 5 plus 5, that's 0. And then 4 over 2 is 6. 0 divided by any number, if you plug into your calculator, you'll see it's 0. And this is what the slope looks like for 0. It means you did not go up or down at all. In this case, I did not go up or down, but I did move 6 units to the right, which is where this 6 comes into play. But I did not move up or down, so this is a 0 slope. 0 slope means it goes straight across. Now let's talk about slope of vertical lines. So again, if we do our slope formula, and we subtract our y's and put them over our x's. So we have x1, y1, x2, y2. I have negative 2 minus 4 over negative 3 minus a negative 3. So negative 6 over 0. And if you plug this into your calculator, you're going to get a domain error, or it will say cannot divide by 0. And whenever you get that error on your calculator, your slope, you need to write undefined, okay? If you leave your answer like this, you're only going to get partial credit from me. You must tell me that when you divide by 0, that means it's undefined slope. And that's when it looks like this, when it's straight up and down like that, okay? Equations for these lines tend to be x equals, in this case it'd be negative 3. So whenever you have there isn't a y, it's just x equals a number for an equation, that's going to be undefined, okay? All right, now let's practice finding the coordinates of given the slope. So let's say that you have 2 ordered pairs. You have negative 4, 5, and then 4 comma r. So we're missing one of the y values, but we know the slope is 3/4. How do we solve that? Well, we're going to use that slope formula. Something I haven't mentioned yet in this video is that we represent slope using the variable m. So that's why it says m equals. And then I've been writing the y2 minus y1 over x2 minus x1. So if we plug in what we know, I could say that y, so in this case, this was my y2, my y1. So r minus 5 would go on top, over 4 minus negative 4 would go on bottom, and it equals 3/4. So then if I simplify and I combine the bottom of the fraction, I would get 8. And then to get r by itself, you have to get rid of that fraction, and you do so by multiplying that bottom number. So you multiply 8 to the other side. So then if you do 8 times 3/4, that's 6. So then you're left with 6 equals that top of that fraction, so that r minus 5. Then you add 5 to both sides, and you know that r would equal 11. Okay, so I was going to write this out and show it to you, But I thought the way that it was written out with like this description on the side, I thought that might be really helpful for you. So I included it for you guys to use, okay? That's why I didn't write out this problem for you. Instead, I just revealed a screenshot. If you have questions about this or anything else from the video, please be sure to reach out for some help. I am happy to help you. I hope you have a great day.